Hello everyone, welcome to my YouTube channel. Today in this video I am going to discuss about the long volumes and long capacities with the help of spirogram. Now we are going to see different long volumes. This is a spirogram, and in this spirogram we need to have knowledge on it about few things. So the increase in the curve or the elevation in the curve means the inspiration, because these values show the volume of lungs, and when you inspire we inhale air and that cause increase in the volume of our lungs. So the increase in the curve means inspiration and the decline in the curve means expiration. So this is the thing we need to know when we will read this spirogram. So this means inspiration, expiration, expiration, and a deep inspiration, so that the volume of the lungs reaches up to its maximum. So this is the way to read the curve. Now we will learn about the different lung volumes. So this lung volume is the tidal volume, and we define this tidal volume as the amount of air that enters or leaves the lung in each breath cycle is known as the tidal volume. The amount of air that enters or leaves the lung in each breath cycle is the tidal volume. Now we'll see the another lung volume. Now we can see this thing is above the tidal volume. So the extra amount of air that can be inspired above the tidal volume with the fullest effort is known as the inspiratory reserve volume, and that equals 3000 milliliters. Now we'll look after the next volume. So expiratory reserve volume. So we see this is also extra to the tidal volume but in the downward direction. Inspiratory reserve volume extra to the tidal volume in the upward direction, but this is extra to the tidal volume but in the downward direction. So this is expiration. So we define the expiratory reserve volume as the extra amount of air that can be breathed out with maximum effort apart from the normal tidal volume. So this is the expiratory reserve volume, that is equal to 1100 milliliters. Now the last long volume, that is the residual volume. So this is the residual volume, and we can define it as the amount of air that remains in the lung even after the deepest expiration or the fullest expiration is the residual volume. This suggests us that even if we expire up to our fullest effort, our lungs do not collapse, and still some volume of air is retained within the lungs, so that lungs do not collapse. So the residual volume is the amount of air that remains in the lungs even after the fullest expiration, that equals 1200 milliliters. Now we will learn about the lung capacities. Inspiratory capacity. Inspiratory capacity, we will again see what it is in this spirogram. So this is the inspiratory capacity. This means that the total amount of air that can be inspired with the fullest effort. The total amount of air that can be inspired with the fullest effort is the inspiratory capacity. So we can calculate inspiratory capacity and other lung capacities with the help of lung volumes that we just studied. So when we look at this diagram, we come to realize that inspiratory capacity is composed of the tidal volume and the inspiratory reserve volume, or when we add the tidal volume and the inspiratory reserve volume, we'll get the inspiratory capacity. So it can be calculated as the sum of tidal volume and the inspiratory reserve volume, that would equal 500 milliliters tidal volume plus 3000 milliliters inspiratory reserve volume. That sums up to become 3500 milliliters. So the inspiratory capacity of a human lung is 3500 milliliters. Now we will see the vital capacity. Again the same spirogram, and in the vital capacity is represented by this arrow. So we'll define vital capacity as the amount of air that can be expired with the maximum effort after the deepest inspiration. So when we define these volumes and capacities, we can define it in our own way, but the thing or the theme of the definition should remain the same. Okay, so we have to get from this point, the topmost point, to the downmost point, so bottommost point. In this way we can define vital capacity as the amount of air that can be expired with the fullest effort after the deepest inspiration. So again we can calculate this vital capacity as the sum of the inspiratory reserve volume plus the tidal volume plus the expiratory reserve volume. So mathematically we can represent it as the sum of inspiratory reserve volume, tidal volume and the expiratory reserve volume. That comes out to become 4600 milliliters. Now we'll see the functional residual capacity. So in this spirogram, the functional residual capacity is represented by this arrow. So we need to define this functional residual capacity. The amount of air that remains in the lungs after the normal expiration. The amount of air that remains in the lungs after the normal expiration, it is the functional residual capacity. We can calculate this functional residual capacity as a sum of the expiratory reserve volume and the residual volume. That mathematically equates as the sum of expiratory reserve volume and the residual volume. That equals 1100 milliliter plus 1200 milliliter. Altogether it becomes 2300 milliliters. Now we'll talk about the total lung capacity. In this spirogram, the total lung capacity is represented by this arrow. So it is the total lung capacity can be defined as the total amount of air a lungs can accommodate, or the volume of air in the lung after the fullest inspiration. So this equals the total lung capacity equals 5800 milliliter, and that can be calculated as the sum of the vital capacity plus the remaining volume, that is the residual volume. So mathematically we can calculate total lung capacity as vital capacity plus residual volume, that equals 4600 milliliters vital capacity and 1200 milliliters residual volume. Okay, so 4600 vital capacity and 1200 milliliters residual volume, that equates 5800 milliliters. So the total lung capacity is 5800 milliliters. The lung volumes and capacities that we discussed is a standard one. So not all the people have the same lung volume and capacities. So what are the things that cause those variations? We'll discuss it now. Lung volumes and capacities will be more or larger with the people with the wide lungs, and also people with more weight, and people who exercise too much, meaning by athletes, they have more lung volume and capacities compared to normal people because of their exercise performances. Young people have more lung volume and capacities, and gradually with aging, lungs, the alveoli, they shrink, and the respiratory performance is not as more as it was in the young age. So next, usually male people, they tend to have 20 to 25% more these lung volume and capacities compared to the female. Again I repeat, the lung volume and capacities we studied earlier, the figures, the numbers, the values, they are standard one, and not all people have the same value. There are various factors that cause variations in the lung volume and capacities. We learned about the lung volume and capacities with the help of this spirogram. If you want to know how to draw the spirogram in your paper or copy, then I have made a separate video on this topic that you can click on the link above and watch. Thank you everyone for watching. If you think this video was helpful, please give it a like, share, and most importantly, don't forget to subscribe. I'll be coming up to you with new videos. Write in the comment section what you want me to make next video on. Again, thank you for watching.